Okay, welcome everybody to this afternoon ESR presentations. Apart from the talks in this morning, we'd also like to hear about the research projects and business plans of our ESRs. The first one is presented by Srikanth. He is pursuing his PhD at Phillips Research and Harvard University in Nijmegen. His interests for speech is mainly in automatic processing of pathological speech. Srikanth, please.
Yeah. Thank you, Zhao. So the topic of the presentation is we call it breathe. This is I would be explaining about the necessity for the respiratory analysis, and then also a brief introduction about how the business model could be and what is the scope for the business in this particular topic. So yeah. The problem, it's quite obvious now. There's a huge burden on healthcare because of chronic respiratory conditions. Like earlier to COVID too, it was, the number of cases with respect to COPD or asthma or chronic bronchitis, all these play a major role and usually is a huge burden on the healthcare. And especially now because of COVID-19, wherein the count today, it's 180 million cases. It's also a huge burden on the healthcare services. So we need some kind of a solution for this. And the best solution would be to have some automatic assessment of respiratory health, which is actually lacking at this particular point of time. And we need to somehow have this assessment in very cheaper ways, like home monitoring or telehealth services, which would support healthcare professionals. But what is the modality that we can choose? One easy modality is speech. And the advantage of speech is speech, as you all know, is a complex behavior. It involves various systems like cognitive system, respiratory system, muscular system, etc. Cognitive system, because we need to have a language model ready and a logic or planning for speaking. Respiratory system, because often it's not much realized, but respiratory action is the basis for speech production. We inhale a gulp of air, and while exhaling, we articulate speech. And muscular system, obviously, because you need to have the muscles involved in phonation and articulation working fine. And any lapse in this synchrony among various systems will lead to disorder, which will be manifested in one's speech. For example, if there's a dysfunction of neurological processing, it would lead to language disorders. And if there's any dysfunction of excitation or articulation, it would lead to speech disorders. So speech can actually be used as a good pathological indicator. And the advantages of using speech is it's non-invasive, it's cost-effective, it's easy to collect. And services like remote health monitoring could be easily arranged. And what is the interdependence between speech and respiration? They are quite highly interdependent, mainly because the source organ is the same, which is lungs. Every time we speak, as I told, we inhale a gulp of air into our lungs. And while exhaling, we are like controlling it by applying a pressure at glottal area and articulating speech. And humans have somehow mastered this smart utilization of lungs over evolution. And not just over evolution, but there's also quite a lot of morphological changes in the vocal tract from infants to adult. Anyway, speech can be visualized as a systematic outflow of air based on the linguistic content and prosodic features of the utterance. And to establish this relation, we need to develop speech breathing models. And we need to do some breathing analysis for conversational speech. And again, the advantage of doing so is by passively monitoring respiration from conversational speech, we can estimate parameters like breathing rate and lung capacity. And we could understand whether a person is having breathing difficulty. So there could be a shortness of breath detection. And finally, we could have a long-term trends in chronic lung diseases like COPD, asthma, wherein we compare the breathing parameters or anything over a long period of time and know whether a person is improving in his condition or declining in his condition. So yeah, the solution is using speech as a pathological indicator for respiratory health. And the approaches are respiratory analysis from speech conversations with agents which are using machine learning or deep learning approaches, and also longitudinal tracking. So here I present a brief idea of how a model of speech breathing looks. So here we train a deep learning model by mapping speech and measured breathing signal, which is usually measured by using respiratory inductive bells. Once the model is trained, we use a new test speech signal and try to estimate the breathing signal. We've been developing this thing. and we could achieve accuracy close to 0.6. And here I would like to show a quick demo of how the speech and the respiration signal as such looks like. So here the blue signal you see is the speech signal, and the red one you see is the ground truth value of respiratory signal, which is measured by using belts. And the green one you see is estimated breathing pattern, which is obtained by using deep learning models. So here's a quick demo.
People thought that the rainbow was caused by reflection of the sun's rays by the rain. Since then, physicists have found that there is no reflection but refraction by the raindrops which causes the rainbows. Many complicated ideas about the rainbow have been formed. The difference in the rainbow depends considerably upon the size of.
Yeah, as you can see, the deep learning models are able to accurately predict how the breathing signal should actually look by directly having speech as an input. So the product we are planning out of this is it's called Breathe, and then it could be either a software or a platform doing respiratory analysis from speech, and this could be used already for Philips respiratory care devices. This could be a software that could be updated into already existing Philips respiratory care devices, or could also be embedded into existing healthcare services like conversational agents or telehealth monitoring systems, etc. And for now, the competitors we have are the telehealth home monitoring services that are already existing, like Medtronic or Honeywell Life Sciences or Abbott. And for the conversational agents, it's the well-known Amazon Alexa, Google Home, and other conversational agents. So the business model we are planning is mainly targeted towards people having respiratory problems, which is also a majority of elderly people. So it could be used into elderly care related businesses. And if people who are already Philips users, they could have a customer membership fees for having this software. Or it could have a product fee for external services like Amazon Alexa or something like that. And our team and specialty, we feel that we have speech experts, AI experts, and speech pathologists. It's a good combination for having a product like this. And we are promising customer relationship to be good by having daily update on health status or having personal insights or advice for self improvement, and also have regulatory updates of platform with state of the art technology. So because it's a software, it could be having some updates which would also use the state of the art technology. So this would be a product for a lifetime kind of. Yeah. So yeah, that's it. Thank you.
Thanks a lot for your presentation. Any questions?
Hello, this is Gauri here.
Hi.
Yeah, hi, hi Shrikant. So the waveforms that you have shown, with which data set have you worked with?
Okay, yeah. So we've developed a data set in Philips Research, wherein we had speech recordings along with respiratory inductive belts. So we had close to 40 healthy volunteers, and
Okay.
these were mostly the employees in Philips Research itself. So we had systematic recordings it was mainly on phonetically balanced paragraphs. So we made people read a paragraph, and then that's how we collected the data.
Okay, thanks. Great.
Apart from that, we also had Compare Challenge last year in Interspeech, which also had conversational speech as a database with the speech and respiratory signal. This was collected in UCL, I guess. So we also made use of that database to evaluate our already existing model.
Okay, yeah, thanks.
Thank you very much for your very interesting talk. I'm not sure if I understood it correct, but is it planned that the system then will alert carers or the users themselves in case of any breathing irregularities, or what?
Sorry, there's a lot of noise coming in. I'm not able to follow your question.
Oh, sorry. Okay, no, I was just asking whether the system you're trying to implement will be able to alert carers of the people or the people themselves in case of breathing irregularities. Or
Sorry.
is
Your
or is
sound
it-
is echoing, and maybe if someone already understood, maybe they can also repeat it.
I have no background noise here in my room, but okay. So can you understand me now?
Yeah, I can.
Okay, then I'll try it again. Are you planning to have any kind of alert for the users or for the carers of the users in case of breathing irregularities, or what is the main aim of the system you're suggesting here?
Okay, the immediate idea we have is to integrate this with telehealth services that we already have. Philips has a huge business called Lifeline. It's in the US for elderly care people. So these are usually when a person actually is in kind of problem, they call and talk to the customer service agents. So the plan is to have this as a, support for that system wherein when a person is talking, we already evaluate their breathing pattern and have an idea of how the breathing pattern is. And by having these calls over a long period of time, we could actually do this longitudinal tracking. So we could estimate breathing patterns, breathing rate, and lung capacity, for example, at different stages of with respect to their calls over a period of time, and say whether a person is improving or declining in his condition. And this could help into early, giving an early alert about the problem kind of stuff. But this is still in the planning process.
Yeah, that sounds very good. Thanks.
Thank you.
Okay, any questions? If there's no question, I have a question for Srikant. You have already explored to record the bright sounds. Have you think about to try to record the breakdowns from COVID patients? Because I saw from in some studies, they recorded the COVID positive bright sounds. Have you already tried for this in Philips?
In Philips, no, but we again tried the interspeech. It's so lucky that every time that we are already exploring, we get the same question in the interspeech challenge. So yeah, there was this COVID related challenge, and then we did try using our models and our already existing models to evaluate whether we can classify whether a person has COVID or not. But we didn't really end up with good results. Our paper was not accepted there. But essentially what we tried is to estimate breathing parameters and then try to classify based on having a threshold for the breathing rate as such. We didn't use any classification related models, but it was mainly on respiratory parameters. So it worked, but it didn't really cross the baseline. Yeah.
Mm-hmm. Okay, thank you.
Thank you.
Any questions? If not, let's move on to the next presentation of Wei. Wei, you could show your slides.
Mm-hmm. Can you all see it?
Wei is studying her PhD at the Center for Language Studies, Radboud University, Nijmegen in the Netherlands. She is interested in the speech intelligibility of pathological speech for developing valid measures for them. Okay, Wei, go ahead.
Okay, thank you, Zhao. Good afternoon, everyone. My name is Wei Xue. Wei is my first name. I'm going to present you the business idea I came up with during the last training event, which is called Intelligibility of Diastatic Speech Automated Assessment Platform. So the first word intelligibility is highlighted because I can imagine not all of you are very familiar with this concept. So I'm going to introduce you first, what is intelligibility? Let's start with our normal communications in our daily life. So two people are talking to each other, they can understand what they're talking about and then give a response. Then they have the communication between them, right? But what about if one of them have dyslexia that can caused by neurological disease such as Parkinson's disease or stroke, then this kind of people, they suffer from losing control of their speech motor system, such as mouth or throat. Then they cannot pronounce very well, so people cannot perceive what they're talking about. Their communication is broken then. That's very sad for them because they can eventually be isolated from the society. And to slow down the progress or to prevent this kind of situation, they can go to the therapist to take intensive therapy to improve their intelligibility. Therefore, to measure the effectiveness of therapy, there's definitely necessary to clearly define what is intelligibility. Well, there are many so different definitions, but in this presentation and in my study, I chose to believe a definition proposed by Hostad in 2008, and that intelligibility is how well a speaker's acoustic signal can be accurately perceived by a listener. So based on this definition, you can imagine that there are so many different kind of metrics can be used to measure intelligibility, right? You can measure it through some Likert scale, like what you do for a product review on Amazon. There also have some clinical tools have been set up, but you can also imagine that only one score per recording or for a person lose a lot of information that cannot provide any insights for the therapist. So then you can also do a transcription, transcribe everything what you hear, right? But a 10 minutes recording requires 4 times to finish the transcription. Even though with some clinical toolkits, it takes a lot of time and effort for both the speakers and the therapist. And if you want to save your time, you definitely have to pay for it, which is really costly. So it's very time consuming and costly, but can provide a lot of information. Then people start to find out some objective ways, and there have been some softwares that focus on the pronunciations, and it's automatic, but then it may contain some nonsense words that need extra effort from the patients, and it's not very flexible because it's based on well set up stimuli. So then our platform came to this way to help both the patients and the therapist. The therapists, if they want to diagnose or provide any feedback for the patients, they need to assess intelligibility, of course. They also need to document, to monitor the progress, and they may also want to do some research to provide insights for other therapists, right? But then all of this takes so much time. And imagine if you all have to do everything manually. So if we have a ASR-based or a machine learning-based automated assessment platform that can take different speech stimuli into account to take the advantage of different metrics and can provide automated intelligibility assessment and at the meantime can document their data, which can also stored for therapists' interest in research. And then to make a profit from it, I have thought about this. I think a free installation in the beginning will be very well to attract more and more people into this. And since it provides the storage of the data and tracking the documents and monitoring the treatment, etc., we ask for annual fee for the hospital depending on the number of the patients. And to create benefit for the patients, they can also cover the cost of some kind of softwares in their phone that they can keep track their monitoring and take some short, simple, minimum treatment. So I have done some survey in the first year of my study, and I'm finished some research and have built up some models So maybe in the future, I'm going to do some marketing pitch after we have tested multiple times and make sure the model would work. And hopefully by the end, we will make some profit from it. Yeah, thank you very much. Any questions are preferred. Yeah, I finished.
Yeah, thank you very much. This is a really interesting approach and goal, I think. Do you already cooperate with therapists, or how will you implement the tasks or the platform? How will it be built up?
Yeah, of course, because it targets a hospital, the therapist is necessary to know their requirements. I did a secondment in Antwerp at the University Hospital Antwerp last year, and I talked with the therapist there, and we agree that, like what I said, that different stimuli provides different results and insights. That's also what I found from my study. And that hospital also well, it's been published now, but a good corpus that includes a lot of recordings from different patients and about different speech stimuli. So that is also a good corpus that we are currently using to build up our model. So
Sure.
yeah. So yeah, if we really want to do this, I think it's necessary to cooperate with a therapist because they have the data, and if we can provide the technologies, as what we discussed this morning, that this collaboration between different fields is indeed will help the progress of this idea, and yeah, and will benefit both sides, I think.
Yeah, definitely. And I think it could be even more interesting because you can also extend it to other related disorders or other kind of speech language diseases, I guess.
Indeed. Yeah.
Cool. Thank you.
Thank you.
Any questions? Okay. I have a question about your cooperation with the hospitals. As you have already did your secondment in Antwerp Hospital, right? I'm curious, how did you process collect the data from the patients, and how did you do that according to the GDPR? Like that agreements? Is there any challenges to do this?
Well, I didn't collect the data from the patients. I reuse the corpus that they collected because their therapists, they have easier access to the patients and they have close connect with them. Well, I did experiments to collect intelligibility from the therapists. So they assess the recordings from different pathological speakers, and it turns out it's very reliable and valid. And maybe not so many therapists are needed to provide these reliable results. But indeed, it always involves a human, so GDPR or the ethical approval is always needed before setting up any this kind of experiments. But I can imagine it would be a challenge. For example, in the group I'm working now, that they used to have some kind of serious game for, so a game that patients can play with, that they need to speak louder and to control, for example, a small icon on the app on a pad, that to walk around to find the key and to finally go to the treasure, to find the treasure. And they first found some patients, but in the background I can see that some of them drop off. due to some maybe personal reasons, and you know, also because they are dysastric speakers, some of them are very elderly, and not all of them are willing to participate or continue the participations. So yeah, it's all still a challenge, I think, in the pathological study field. Yeah.
Yeah, thanks. Okay, I'm also curious if it is necessary to analyze the speech intelligibility according to different kinds of diseases. I'm not sure what you are doing, general speech intelligibility analysis, but in the therapy, practical therapy procedure, I'm curious if there's some difference between the intelligibility between different diseases such as mental health or oral cancer and other diseases.
Yeah, that's a good question, because people with different dysarthria and also maybe what bands do for the people who have the oral cancer removed, something like that, they have different characters in their speech. So therefore, it's better to classify them, or you treat them separately, for example. And also it definitely will influence the performance of the model, because for example, some Parkinson patients can speak very fast, but they may don't have problem with articulate correctly. So, but that will also influence the intelligibility, right? Because you hear someone speak so fast and it's not normal and comfortable. Yeah. So in that case, you need to you need to have different data set, and intelligibility also have to be studied differently with different dysarthria.
Makes sense. Thank you very much, Wei. Anyone has any more questions? No? Okay.
Yeah, thank you.
Thank you very much. Is Zheng Jun in our meeting?
I don't think so. I'm gonna send her a message.
Okay. Originally, she will be the next one. Will she be able to present today?
Well, Eno, or we can present with Eno. I don't know.
Yeah, I don't know where she is.
Yeah, just 1 minute. I sent. Maybe you can like skip us and we go back just after. And if she doesn't come, I can present. It's fine.
You are the final one today.
Ah, okay. 1 minute. Well, I'm gonna present anyway. It's probably easier. Yes, can you see my screen?
Yes.
Okay. Well, I haven't prepared anything, so sorry in advance. It was supposed to be the intro, but that's fine. That's fine. We made the slide together, so it's gonna be fine. So the idea today was to present what the business plan we came up with in the last TAPAS event, and our idea was to provide an atypical automatic speech recognition library that we call our atypical from ICER and atypical. And first to present, as an introduction, we wanted to present what is atypical speech and how does it differ from what we call typical speech. So atypical speech is traditionally accented speech, so from regional accents, but also pathological speech. So it's really interests us in our context of the TAPAS event, and also children's speech. And all of them differ from like normal adult healthy speaker even though like accented speech is adult speaker, like it's a differ because the way they speak is different from the traditional like huge data sets that we can find in the wild. So the problem that we find out that we wanted to answer is when you use traditional ISR system that are used traditionally, like say in Google Home and Google Siri devices and all this kind of stuff, like it's work well for what we call typical speech. But when it comes to atypical speech, when you use this exact same model, like the recognition score is like really, really bad. And for you to trust us, we show here some like score. So it's whatever rate score. So the lower it's better. On the left, we have Japanese recognition. So we have a system trained on normal Japanese speaker, so typical Japanese speaker with so non-dysarthric, and we have also some dysarthric speakers. So I plot here a Japanese dysarthric speaker, and as you can see, the water rates is like there is a huge gap between the non-dysarthric and the dysarthric one, and the score, so lower is better, is quite good for the non-dysarthric, and it's like jumping a lot for dysarthric speaker. And I did the same experiment for children, and that's exactly the same. So I train a system on adults, and the score are quite good. And when we test with the exact same system, the children's score is like degrading a lot. And this is trained on European Portuguese children. So the main problem that's make like automatic speech recognition system for atypical speaker that people don't use ISR system for atypical speaker is because it's require a lot of expertise, because you need to know a lot about the different type of atypical speaker. So if it's a disease, you have to know how the disease affects the voice. If it's a children, you have to know how children's speech is different from adult speech. If it's an accent, you have to know where is the accent and how does this accent work. So that's require a lot of expertise. And of course, because you have to go through this process of like find out what is happening is like time consuming. And most of all is very expensive, because like having expert to work on that is very, very expensive. And the goal of our idea was to kind of avoid company and avoid our clients to go through this process, and to directly provide what we call atypical library, where when you provide atypical speech through some of our model, like the recognition score is good. We plan in our business, we plan, since we are working on pathological speech and children, we plan to so far only include these two. So this is how we plan to make money. This is our business model. So the goal is to have an easy to use open source library, but we provide some different pre-trained models. So like on children, different pathology, where the client have to buy the model, the pre-trained model, and you have to buy the one lifetime license per model. And of course, we're gonna like update the model over time. The goal is to have a very user-friendly documentation. So if like a company want to use our model as a pre-trained system and then adapt for a particular speaker, it's very easy to do. Of course, we want to provide some maintenance, so update the model, use new state-of-the-art methods to improve our model. And also we want to do some online classes, so where we can learn to people how to use our library. And of course, since we have some knowledge on atypical speech, we wanted also to do some consulting. And during this consulting phase, we can also promote our atypical library. So the customer segments. So this is we just plot 3 of them, but our idea is to target some company that are working with speech, not necessarily atypical, or even like automatic speech recognition company. But the goal was to say, okay, if you need it, we can provide something. And yeah, so we have Lalilo, which is a company, French-based company, where they provide reading assistant tutor for children. therapy box. That's most of us we know it. We know them though, so they are London-based and they're working with pathological pins. And of course, since with this morning, we all know Ring, of course, and many more, of course. So how do we reach them? So the goal of to like let them know that we exist and that we provide that. Well, we can do it through conferences because most of the time this company that are interested in this topic are in these conferences. And of course, since we are in a quite small, I insist on the word, quite small field, like word of mouth can be very useful too. And we plan to do some advertisement. And of course, if we like publish state-of-the-art model, some publication can be like a very good advertisement too. So why us and who we are? So we are like so I'm Thomas Roland. There is Enno Herman and Zenjun Yu, and we are both like all of us are PhD students within the TAPAS program, and we all work on atypical or children's speech recognition. And yeah, so that's also we didn't set up the social media yet, but in case we plot it here. So yeah, thank you for your attention. I hope it was not like too messy, but I think it was fine. Yeah, and that's all.
Thank you very much for interesting presentation. Any questions?
Stop sharing.
Oh, okay.
Oh, Zenjun is here.
Oh, great.
Oh yeah, hi. Sorry, I just jumped from another meeting, and yeah, but Thomas hand it over very well. Thank you.
I did my best.
Yeah, sorry, I think we started a bit too early with your talk then. Okay. So I have two questions. So the first one is, how are you recruiting the children?
We can like for instance in Lalilo, so the French company, they are like doing kind of collaboration with schools. So they provide like tools for the school, and they say, okay, if you want to use this tool, well, you can also participate by like recording children, of course, according to the GRPD. But yeah, like if they need it, yeah. And also there is some database for children in the white that are available.
Mm-hmm. Cool. Yeah, thanks. And then maybe you could share your screen again, because I
Yes.
have a question to one of your slides where I'm not sure. Yeah, and the slide is the problem statement slide with the word error rate. So quite at
this
the
one.
beginning. Yeah, exactly. I didn't really get this slide. Maybe you can explain me again.
So the goal here of this slide was to show that the normal typical system, ISO system, automatic speech recognition system, are not working well with this atypical speaker. So on the left, we have the pathological part, and on the right, we have the children one, because these are the two we focus on. And so the score is whatever rate. So the lower it is, the better it is. So it's yeah, the lower it is. And yeah, like for the left one on the dysarthric and non-dysarthric. So the non-dysarthric, so the typical the score is quite low. It's quite low, and for the dysarthric speaker, like the score is like a lot, which means the recognition is like super bad, and that's exactly the same for children. For adults, when you use this automatic speech recognition system, the score are quite good, but for children, like the score drop a lot, and the recognition is not good.
Okay, yeah, great, thanks.
Okay, any more questions? No, okay. Okay, so these are our three ESR presentations in this afternoon. We will have more ESR presentations tomorrow afternoon and in the afternoon of 30th of June. So look forward to see you again tomorrow morning to our event. We will have 3 talks and ESR presentations, ESR discussions, and a final Augsburg tour tomorrow. Yeah, okay. So thank you very much for all of your time and see you tomorrow at 9 o'clock.
Thank you. Bye.
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 Thank you. Bye.